Welcome back to the virtual classroom of Chem-based School of Chemistry. Let's continue the discussion on alkanes. In fact, in the previous lesson, we started on the chemistry of alkanes. We discussed about the chemical properties and the physical properties of alkanes. And then I went on to explain the fractional distillation of crude oil, the cracking reactions, the reformation reaction, and the environmental pollution was discussed, and the alternative methods which was used to minimize environmental pollution, the alternative fuel sources like such as solar energy, and then the hybrid energy. Also, the fuel cell was discussed. I think we have to continue from question 17, carbon footprint, on the page 5. As for the carbon footprint and the carbon neutrality, the carbon footprint is the measurement of the total amount of total mass of carbon dioxide gas produced by a fuel due to its combustion, right? So the carbon footprint gives us the understanding of the total amount of the carbon dioxide produced from a fuel due to its combustion. So the carbon footprint, it's not just the carbon dioxide released upon the combustion alone. We have to count the carbon which is released due to its transportation of the fuel, refining process, the reformation process, and during distribution, because fuel, when you calculate the carbon footprint, in the extraction process, there is carbon dioxide released, and then its distribution process, because these are carried by the vehicles. So the carbon dioxide is released by the vehicle, and also the extraction process requires, it will release carbon dioxide to the atmosphere. So when you talk about the carbon footprint of a fuel, it is not just the carbon dioxide produced by the fuel at the point of combustion. It is not just at the point of combustion. Rather, we have to consider the carbon which is produced during the transportation, the extraction process, reformation process, refining, cracking, distribution, all those, right, from beginning till the end. Amount of carbon released should be calculated when you calculate the carbon footprint of a fuel, right? So if you take, for example, a biofuel, so when you take a biofuel, then we have to, because when the biofuels are made, a certain carbon dioxide is absorbed during the formation of the biofuel. Because, for example, if you take firewood, right, it's also fuel. So a certain amount of carbon dioxide absorbed. For example, if a tree is, say, we took firewood from a say 100 years old tree, so there is a certain amount of carbon dioxide, good significant amount of carbon dioxide absorbed during that period of 100 years, for example. So when you calculate the carbon footprint of such a biofuel, then you have to subtract the amount of carbon dioxide released during the combustion, transportation, and distribution process, minus the amount of carbon dioxide absorbed during that 100 years of time. So the carbon that we understand, the biofuels, even though it releases carbon dioxide, but the carbon footprint of a biofuel is much less than that of a fossil fuel, right? So generally, any fuel will have a carbon footprint. There is nothing called a zero carbon footprint. Even if you take firewood as a fuel, then that also has a significant, but compared to the fossil fuels, much less, because it absorbs carbon dioxide. So remember, when you calculate the carbon footprint, remember, it's not just the carbon dioxide produced at the point of combustion. It is combustion plus is extraction of the fuel, where to count, because say, even if you take fossil fuel, there's so much of materials and the manpower, all those releases carbon dioxide, right? For example, if I take just a simple example of a tree, right? When you calculate the carbon footprint of a tree, see, it's not just the carbon dioxide release. Say, for example, you cut off the tree, then you need some equipments, right? And even people have to come for that process. They don't come on horseback, they have to come on vehicles, so that those vehicles releases carbon dioxide, and that also have to be counted, right? So, and even the equipment used to extract this fuel, meaning to maybe you need a saw, you need axe. These equipments doesn't come from the heaven, you have to manufacture them, right? So that manufacturing process, so much of carbon dioxide is released. So the argument goes on. It's a lengthy argument because you have to even in the count all those in the extraction process. Then after cutting down the tree, then you have to uh, you know transport it. So that is also should be added, right? And distribution process, the carbon dioxide is released. So all those have to be, even if it's a fossil fuels, right? Even fossil fuels extraction, there is a involvement of the carbon dioxide release. Then you have extraction process, and then it goes on like even distribution. A certain amount of carbon dioxide is released, right? So all those have to be counted when you calculate the carbon footprint. Right? As for the carbon neutrality, if the carbon dioxide absorbed by the fuel, if it is equal to the carbon dioxide released at the point of combustion, if it is equal, that will be a carbon neutral fuel. Generally, practically, there's nothing called carbon neutral fuel, right? Because even if you take, for example, argument's sake, right, we'll take a plant or tree for 100 years is absorbed this much of tons of carbon dioxide. X tons of carbon dioxide was absorbed by the plant, by the tree for 100 years. So you take the wood out of the tree and you burn it. For argument's sake, we'll say X amount of tons of carbon dioxide was released through the combustion process. It's just for the argument's sake, right? So if that is the reality, then we say such fuel is carbon neutral. The amount of carbon dioxide absorbed for the manufacturing of the fuel, if it is equal to the amount of carbon dioxide released upon the combustion, then if that both are equal, then we say it's a carbon neutral fuel. But practically, when you calculate the carbon dioxide released by a fuel, we have to consider so many other factors. Like as I explained before, the distribution amount of carbon dioxide released during the distribution of the fuel, during extraction of the fuel, and all those have to be counted. So when you count all those, even to the extent, right, the equipments used for the extraction, right, all those equipments, you have to count the carbon dioxide released to manufacture those equipments. So it's a lengthy discussion likewise. So even if you say you're driving an electric car, right, and at the back of this car it says carbon neutral and zero emission, this is not true, because it is true at the point of driving the vehicle. Yes, you're not going to release any carbon dioxide when you're driving an electric vehicle, but how did the electric vehicle come into existence? It didn't come from the heavens, right? People made it, right? So for that process you need iron. So iron was extracted how? By the hematite, right? So hematite, to extract that, so many trees have been chopped off, and to put up this plant, so many trees have been cut down, and so many equipment, so much of carbon dioxide released at that point. So it goes on like that. So it's very hard to prove that a given fuel is carbon neutral, but there are certain fuels which is very close to carbon neutral, certain biofuels. Yeah. So even the energy produced by a windmill, for example, it is not carbon neutral. because windmill, to make those blades and those huge towers, you need cut down so much of trees and plus extract iron. So even that you cannot prove as a carbon neutral. Yeah, right. Okay, so let's read the note. Carbon footprint measures the total amount of greenhouse gases produced by a process. Carbon footprint measures the total mass of carbon dioxide produced by a fuel from its production to its combustion. The carbon footprint of a fossil fuel is the amount of carbon released on combustion plus the carbon dioxide released due to its transportation, refining, and distribution. As for the carbon footprint of a biofuel, it is the amount of carbon dioxide absorbed during the growth should be subtracted from the total mass of carbon dioxide produced on the combustion. This means that although a biofuel releases carbon dioxide, the carbon footprint is much less than a fossil fuel. No fuel has a zero carbon footprint. Even hydrogen has a considerable footprint as it is made from methane. Even if you're using, for example, as I mentioned last week, the fuel cell, which we use hydrogen gas and oxygen gas, a series of reactions take place and electric current is produced. Even fuel cell, even manufactured of hydrogen, even if you use hydrogen as a fuel, like in the fuel cell, it is not carbon neutral. I mean, it's not. It has a significant carbon footprint because extraction of hydrogen currently is done by methane. If that's the cheapest, right? Not by water. Water is costly because extraction of hydrogen from water involves a high energy electrolysis, which is costly. So currently, it is done by the methane, right? So methane is extraction of methane. It releases carbon dioxide a lot to the atmosphere, right? So even hydrogen, if you use directly, it is not a carbon neutral fuel or carbon. It has a significant carbon footprint, right? So carbon neutrality, a process is said to be carbon neutral if the carbon dioxide or other greenhouse gases released by the substance is balanced by the action which removes the equivalent amount of carbon dioxide from the atmosphere by that substance. No fuel is carbon neutral. The term carbon neutral is often misused to denote no net carbon dioxide produced at the point of use. Thus, biofuels and hydrogen are sometimes described as carbon neutral by ignoring all the carbon dioxide released before they are used. Right? For example, if you're driving an electric vehicle, already you have done the pollution somewhere in the world. Right? At the point of using it, there's no pollution, but pollution is already done. Right? Similarly, energy produced by wind turbine also not carbon neutral as the manufacture involves high energy process. Yeah. So you know what is the carbon footprint and carbon neutrality. Any questions? No questions. The next one, describe and apply the concept of carbon neutrality to different fuels such as petrol, bioethanol, biodiesel, and hydrogen. So I've given a discussion here how to apply this carbon footprint and carbon neutrality for various fuels. So let's read the note. Petrol has, as any other fossil fuel, produce carbon dioxide upon combustion. Therefore, it is not carbon neutral. Biofuels are made from renewable organic materials such as bioethanol, biodiesel, have a carbon footprint because fertilizers and fuel are used when the plants are grown. Bioethanol is manufactured by the fermentation of carbohydrates. In recent years, there have been a rapid expansion of the production of bioethanol as a fuel, particularly in countries like Brazil and USA. The apparent advantage of the bioethanol is that it is carbon neutral, some almost carbon neutral, not exactly 100%. Some quantity of carbon dioxide is given out as the amount of carbon dioxide absorbed during photosynthesis. So biodiesel is made by mixing vegetable oil with methanol and acid catalyst. This reduces the methyl ester of the unsaturated acids. A typical methyl ester in biodiesel is given here, which is the formula of the methyl ester. Biodiesel have similar combustion properties to diesel produced by petroleum. As fuel is used during the growth of crops to obtain vegetable oil, biodiesel still leaves a carbon footprint. Biodiesel made from soybeans reduces the emissions by 41% compared to this. This is a discussion of various examples. This is important for your MCQs. Hydrogen gas, when combined with oxygen in fuel cells, produce electricity to power motor vehicles. As hydrogen is not found naturally, it is currently manufactured by methane reacting with steam in a catalytic process and produce carbon monoxide and hydrogen. The hydrogen gas is produced by natural gas methane and it produces carbon monoxide. That's a byproduct of the reaction because methane produces carbon monoxide and hydrogen, and it has a significant carbon footprint. If renewable energy is used in the manufacture of hydrogen, then it will be carbon neutral. All right. So let's look into the reactions of alkanes. As I mentioned last week, alkanes show a limited type of reactions, a combustion reaction and substitution reaction. Now, combustion is a scientific term for burning, which is the reaction with oxygen. There are two types of combustion. The type of combustion depends on the supply of oxygen. There is complete combustion, which happens in the presence of a plentiful supply of oxygen, and you have incomplete combustion, which happens in the presence of limited supply of oxygen. So the complete combustion, the products of complete combustion are carbon dioxide plus water, whereas the products of incomplete combustion is carbon monoxide plus water. Even sometimes carbon and water also can be produced. Carbon soot and water can be produced. That depends on the supply of oxygen. If the oxygen is much less, it can produce carbon, just carbon without carbon monoxide. With slightly more oxygen, carbon monoxide, and excess or plentiful supply of oxygen, carbon dioxide plus water. So remember, combustion, the complete combustion releases carbon dioxide, and it will also releases more energy, right? More energy can be released by the complete combustion. As for incomplete combustion, it only releases a limited amount of energy, right? So, right, let's see. All as we know, when hydrocarbons are burned, as I explained last week, the smaller hydrocarbons, the smaller fractions of hydrocarbons, the lighter ones like diesel and naphtha, when you burn them, you get less energy compared to the long chain heavier fractions like diesel, for example. Diesel is a long chain fraction. So when you burn diesel, it gives a lot of energy. That's why the heavy vehicles, they use diesel, right? Because it releases more energy. So hydrocarbons, as the number of carbon atoms increase, what happens is that the energy released will be more. So long chain hydrocarbons releases more energy compared to the short chain hydrocarbons. Right? So let's write a common general equation to represent the combustion of alkane. As I mentioned last week, the general formula of alkane is CnH2n plus 2. So the complete combustion produces carbon dioxide plus water. I give you a few seconds. Quickly balance this in terms of n, using n balances. So that will be a common general equation for the combustion of alkanes.